The lesson objective of this video, students find measures of angles inside and outside of circles. So first of all, if a tangent and a chord intersect at the point of tangency, then the angle is half of the arc. If a tangent and a chord intersect at the point of tangency, then the angle is half of the arc. So it's very similar to when we had inscribed angles. Same idea. The vertex is on the circle, so we still end up with half the arc. So for example, if I tell you that this arc is 240 degrees, then I would know that this angle was half of that, or 120 degrees. And likewise, then if I told you this was 60 degrees, you would know that the arc was twice as much, or 120. And again, it makes sense. A circle is 360 degrees, and a line is 180 degrees. So it makes sense that it would be half, since 180 is half of 360. All right, so let's take a look at example 1. Line M is tangent to the circle. Find the indicated measure. So I want to find the measure of angle 1 for part A. And the arc is 132, so I know that the measure of angle 1 is going to be half of the arc, so it's half of 132. And so that comes out to 66 degrees. All right, then for B, we need to find the measure of arc EFD. So for that one, we're starting at E, we're going through F and around to D. So go ahead and figure that one out. You should get that it's twice as much, or 220. Alright, so if I have angles that are inside of a circle, that's the first thing we're going to talk about. If two chords, if two chords intersect inside, so right now we are talking about inside the circle, and then each angle is half of the sum of the measures of the intercepted arcs. So the measure of the angle that is inside the circle would equal half of the arc plus the other arc. So what's really important to remember is that when you're inside, it's the sum. You're inside means you're adding. So in my figure here, the measure of angle 1 is going to be half of the arcs that it's intercepting. So it's intersecting AB and CD. So it's going to be half of the measure of AB plus the measure of CD. And if I'm looking at angle 2, then that's intercepting these two arcs. So the measure of angle 2 would equal half of the measure of arc BC plus the measure of arc AD. So in essence, the angles inside are the average of the two arcs on the outside. So for a more specific example, we're going to find the value of x. So the chords F, H, and G, J intersect inside the circle. I've got both of the arc measures already given to me. So x is going to equal the average of those two numbers. half of 140 plus 112. So I add those together and I get 252. And so half of that, x would equal 126 degrees. Next, we're going to look at angles outside of a circle. So when I have two lines that intersect outside of the circle, then the angle formed is half of the difference of the intercepted arc. So the angle on the outside is equal to 1/2 of the big arc minus the little arc. So again, it's important to remember that if it's outside, we are subtracting the difference. And maybe one way you can remember it is that when you get left out, that's a negative thing. And so you subtract when the angle is outside. But if you're on the inside, that's a positive thing. And so you add when the angle's on the inside. All right, so when we have two lines that are intersecting outside of a circle, we have three possibilities. We might have two secants. We could have one secant and one tangent. Or we might have two tangents. But whichever situation it is, we're still going to use that same equation, half of the big arc minus the little arc. So let's take a look at an example. We want to find the value of x. It says the tangent GF and the secant GJ intersect outside the circle. So that means the angle is going to be half of the big arc minus the little arc. So my big arc is out here, and my little arc is 72. I don't have the big arc, but I know that all of the arcs have to add up to 360. So if I take 118 and add 72 to it, those two add up to 190. And so then I can take 360 and subtract 190, and I get that what's left over is 170. So the big arc is 170 degrees. So x is going to equal half of the big arc, 170, minus the little arc, 72. And so that means x is half of 98. And so it equals 49. Alright, now we're going to look at one with two tangents. Here we have to find the value of x. And it looks like they haven't given us anywhere near enough information, but actually they have. On this one, if I know that this part is x, and the whole circle is 360, then this part out here is going to have to be 360 degrees minus x. So the angle is half of the big arc minus the little arc. So I fill in what I know. The angle is 45. I know that. And my big arc is 360 minus x. And my little arc is just x. So simplifying that, I combine my like terms, and I get 360 minus 2x. And since those are both even, I can go ahead and take the half. So half of 360 is 180, half of 2 is 1. So 45 equals 180 minus x, and so we end up getting that x is equal to 135. All right, so now I've got some for you to try on your own. So first, take a look at number 1. You're going to find the measure of arc ACB. That one's pretty straightforward. You should get that. You just have to double the 120, and it's 240 degrees. All right, take a look at number 2. This one you're going to solve for x. So go ahead and pause the video now as you work it out. Okay, before you can solve number 2, you've got these two. Oops. They've given you this arc and this arc, but the angle that they gave you is over here, 52 degrees. So the first thing you want to do is figure out what the angle is that's related to the two arcs that they gave you. So they're a linear pair. I can just take 180 and subtract 52, and I find out that this is 128. So then you're going to use that angle, and it's going to equal half of the sum of the arcs. So one of the arcs is x, and the other one is 144. And if you want to get rid of the half, you can double everything. So we get 256 equals x plus 144. And when you subtract the 144, you should have gotten that x was 112. Next, I want you to try a problem, number 3 here, and now the angle is on the outside. So pause the video. Okay, so the angle on the outside, it's not good to be left out, so it's negative, it's where you subtract. So the angle is equal to half of the big arc minus the little arc. So the angle was 26 degrees, and that's going to equal half of y minus 30. And then to get rid of the 1/2, you can double everything, and we get 52 is equal to y minus 30. And so when you add 30 to both sides, you get that y is equal to 82. All right, number 4 is a tricky one. And you actually have to use trig functions to figure that one out. So why don't you take a look at number 4, puzzle with that one for a little while. Pause the video and try to do it on your own. So this one is pretty tricky. We're still going to use the same thing. The angle is half of the big arc minus the little arc. And so what you have to do is you look at, oops, sorry about that, you look at this triangle here. I'm going to go ahead and move it down so I can work with it. Alright, so I've got C, D, and E. And they told me that this part was 2, and the radius is 4. So I know this is 4, and I know this is CE is 2 plus 4, so this side is 6. And the angle I want to know is right here. So I'm going to use, let's see here, I've got the opposite and the hypotenuse, so I'm going to have to use sine. So the sine, the inverse sine that is, of 4 over 6 is going to give me angle DCE. And so if I go ahead and put that in my calculator, I get that it's approximately 41.8. So then to get the entire angle DCA, I just have to double it. So the measure of angle DCA would be about 83.6. So now I'm going to use that in the formula to determine what A is. So give myself a little more room here. All right, so that means that 83.6, the angle, that's outside has to equal half of the big arc, which was A, minus the little arc, which is 360 minus A. And so 83.6 would equal half of 2A minus 360. Because when you distribute your negative here, this becomes a positive A, and that becomes negative 360. Alrighty, and then go ahead and take half of that. And so 83.6 equals A minus 180. And so it turns out that A is equal to 263.6. And that concludes this video. Thank you.